Hello everyone, welcome back. Today let us discuss about the applications of Fourier transform in electronics and communications. So let us start with the introduction. The Fourier transform is a mathematical technique used to analyze signal and understand their frequency components. It is widely used in electronic and communication systems for various applications. In this presentation, we will explore the different application of Fourier transform in electronic and communications. So let's move on to the signal analysis and filtering. The Fourier transform helps in analyzing the signals by decomposing them into the individual frequency components. It enables us to understand the frequency content of a signal and identify specific frequencies. Filtering techniques such as low pass, high pass, and band pass filters can be implemented using Fourier transform for noise reduction and signal enhancement. So let's move on to the spectrum analysis. Fourier transform allows us to obtain the frequencies spectrums of a signal which represent the distribution of frequency components. Spectrum analysis is crucial in applications like wireless communication, where different signals need to be separated and analyzed. It enables us to identify interference, noise, and other frequency components that might affect the communication system. So, the next is modulation and demodulation. Fourier transform plays a significant role in modulation and demodulation techniques used in the electronics and communication system. Modulation involves shifting the frequency of a signal to carry information, while the demodulation is the process of recovering the original signal from the modulated signal. Fourier transform helps in understanding the frequency shifting and recovery process, ensuring reliable communication. So let's move on to the image audio processing. So Fourier transform is extensively used in image and audio processing application. It enables us to analyze and manipulate images or audio in frequency domain. Technique like image compression, noise removal, audio equalization, and spectral analysis rely on Fourier transform for efficient processing. So the next is channel equalization. In communication system, Fourier transform aids in channel equalization. It helps in compensate for the frequency dependent attenuation and distortion introduced by the communication channel. By analyzing the frequency response of the channel, appropriate equalization techniques can be applied to recover the transmitted signal accurately. So let's move on to the radar and sonar systems. Fourier transform is essential in radar and sonar system for targeting detection and localization. It allows us to analyze the echo signals received from the targets and extract their frequency information. By applying Fourier transform, techniques can be identified and track targets accurately. So the next is spectrum sensing and cognitive radio. Cognitive radio system utilize the Fourier transform for factor sensing. It helps in detecting and identifying unused frequency bands or spectrum holes. By analyzing the frequency content of the radio spectrum, cognitive radios can effectively allocate and utilize available spectrum resources. So let's move on to the power spectrum estimation. Fourier transform enables power spectrum estimation, which is crucial in various communication applications. It helps in determining the power distribution of a signal across different frequency components. Power spectrum estimation is used in areas like wireless communication, signal analysis, and system optimization. So let's move on to the audio equalization. Fourier transform plays a crucial role in audio equalization techniques. It allows us to analyze the frequency response of an audio system or recording and apply appropriate equalization filters. By manipulating the frequency components, we can enhance or modify the audio quality or desired. So let's move on to the speech processing and recognition. Fourier transform is extensively used in speech processing and recognition application. It helps in analyzing the frequency content of the speech signals and extracting relevant features. Techniques like speech recognition, speaker identification, and speech synthesis rely on Fourier transform to accurate processing. So the next is wireless communication. Fourier transform is fundamental in wireless communication system for signal analysis and processing. It enables us to analyze the channel characteristics, multiple fading and interference. By understanding the frequency components, wireless systems can adapt their transmission parameters for efficient communication. So the next is image compressions. Fourier transform is widely used in image compression techniques like JPEG. It helps in transforming the image into frequency domains where high frequency components can be efficiently compressed or removed. By according less important frequency components, image compression algorithms achieve significant data reduction. So at last the conclusion. Fourier transform is a powerful mathematical tool with numerous applications in electronic and communication systems. It enables signal analysis, spectrum analysis, modulation or demodulation, image or audio processing, and more. Understanding the application of Fourier transform helps in designing efficient electronic and communication system. Thank you.